Okay, you may now start the recording.
Tang,
So, good
tang,
evening po
tang,
ulit,
tang.
Sir J and Josh. So, this will be our um, last sets of sessions siguro for nuclear chemistry. This time, we'll be answering the practice set I gave to Joshua. So, let me share screen lang, no? Ayan, medyo ano naman to, Josh. Mas maano mo na siya. So, we have two parts for the practice set. The first part will be all about nuclear reactions, more on balancing and predicting the uh, modes of decay. And then for letter B, calculations about nuclear chemistry. So hindi lang yan na this is not limited to binding energy and kinetics as well as yung mga radioactivity units, etc. Okay? So ayan. So ayun, you can annotate na pala. So for letter A, you just need to predict the products and balance the nuclear reactions given. Sige, for number one, Josh, go ahead.
Ito po, tawag po dito big brain time.
Okay. So ayan, sige. Gawin na natin yung 1 to 7. 1 to 7.
Obo.
Okay, I'll give you time muna, no? Sige, go ahead lang.
How
1
to
to
delete
7.
delete without deleting.
You're adding square boxes ba? Then with white,
Opo,
ano?
white.
White background. Okay. Okay, good. Sige. Don't forget to include properly. Ayan. I-move mo na lang kung gusto mo yan. Include properly the atomic masses and their um, atomic numbers.
Tama po.
Let me check.
What?
Okay, let's see. Okay, so let me check. For number one, we have uranium-238. And then, what's your byproduct for this one? Anong byproduct
Sodium
mo?
234.
Ah, I know what type of radiation produced.
Alpha.
Okay, so uranium-238 is an alpha emitter. So kapag alpha, let's summarize again para this will be our basis for answering, no? Pag alpha decay, Josh, what happens to your atomic mass?
-4.
Very good. And then for your Z, or atomic number, -2. Okay. And then, you'll produce an alpha particle, no? So, of
Opo.
course, alpha particle is what again? What's the identity of alpha particle?
Yung helium-4 nucleus.
Okay. The helium
Ano po, bakit,
nucleus.
bakit po nagkaka-double beta decay sa uranium-238? Di ba marami na po
Double.
siyang marami,
Mhm,
marami na po siyang marami na po siyang proton. Bakit
mhm.
siya dadagdag pa po?
Proton. Beta decay for
Double po.
uranium-238.
Sabay po na dalawa. Double beta decay.
For this is for uranium-238, no? I think the stability of the uranium-238. Wait lang. Is this a side reaction? I think this is the
Sometimes
main reaction, eh.
it happens po sometimes, very rarely.
Mhm, mm.
It accounts for mga 60% ng ano po, plutonium other than yung mga
Other than
freak activity.
thorium. Mm.
Opo, other than thorium, tsaka yung mga iba pong mga freak accidents.
Ay, wait lang. From uranium-238, you will form, okay, double
Plutonium-238.
beta decay to convert uranium to neptunium and plutonium.
At,
Tama,
opo.
no?
Hindi,
Okay.
hindi po siya magko-convert into neptunium. Ano na po, ano na po siya, diretso sa plutonium.
Okay. Plus 2 beta negative.
Yun po yung ano, mga few
Mm.
na talagang sabay
That's the
po.
reaction. Yeah, oo. Parang ganito. Wait lang ha. I'll move this one. Sa,
Oh no.
ayan, yung mga parang ganito. Okay, later um, you'll see reactions like this, no? Producing several particles. Huwag kang mag-alala. Ayan. 'Di ba? Balik na siya. So, I think for this one, kaya siya nagkakaroon from uranium-238 to then experiencing beta decay, no? So, like what I've mentioned last time, yung modes of decay mo, these are not really perfect or this will not be uh, constant for your atom. So
Kaya nga po,
actually yung
why does it even have a chance to occur? Kasi dapat po, it
yeah.
should not.
Mm.
Tataas
Kasi
pa
'di
po
ba
siya
pag
eh.
ano,
Tataas din yung Z
oo,
eh.
pag Z is kapag Z automatic Z greater than 83, automatic it should be the alpha decay. So yeah, I think the parang most plausible explanation for this one is um, since your nucleus it's unstable, the most possible decay will be alpha decay. But we don't also neglect the fact that since your nucleus is unstable, it can also undergo other types of decay. Pero yun nga lang, hindi sila yung major decay mode mo. 'Di ba naalala mo yung yung um, example natin for potassium 40, yung potassium argon dating?
Abo.
Yeah, because if you will recall, 11% lang doon yung electron capture and then the rest will be beta decay, right? So I think that's a similar situation, no? So parang ganun, bakit nangyayari yung electron capture for potassium 40 pero dapat the mode of decay should be beta. Okay? So beta decay kasi ano yun you have a high neutron proton ratio. 'Di ba ang electron capture, if I'm not mistaken, it should only happen if
Yun din po.
balik tayo sa ano,
Why does it even, why does it have a tendency to, why does it even have a
to do.
tendency to turn into argon?
Instead na ano 'di
When,
ba, parang low neutron
papalitan
proton
po eh.
ratio, doon lang
Kumbaga po,
mag-electron
oo.
capture. Correct.
Kumbaga po, parang
Mm.
yung, parang carbon 14, magpo-positron decay.
Mm.
Parang ganun
Correct.
po eh.
Mm. That is a really really good question or really good observation. So ayun nga ang pinaka plausible decay ko na ay possible explanation dito is since your nucleus is really unstable, we can predict the major mode of decay but we can also um, deny the fact that other modes of decay can happen and this can be only observed through experiment. So, yun. So, I think sa experimental mo talaga siya mapuprove na nangyayari siya. Ngayon, ang explanation ko, nisip ko kung theoretically speaking, um, may mga may mga nucleus na even though it's kunwari uranium-238 siya, there are certain nucleus of your or nuclei of uranium-238 instead of undergoing alpha, nagbe-beta sila because that might be the most baka siya yung magiging most um, possible way to become stable pero parang hindi rin naman kasi magiging plutonium nga siya no or I'm thinking
May
din
either,
'di ba
baka may,
kasabay
may
para ma-balance
irregularity po
out.
sa ano? May
Yeah, I
irregularity
think
po
may
po sa,
irregularity dun sa nucleus It's
o
still
kaya may, opo.
uranium-238. It's still
O kaya may
uranium-238.
irregularity sa weak nuclear force.
Mm-hmm. And then that's the reason why you can have this opposite, no? Instead of having the alpha decay, parang nag-beta decay pa siya. Yung opposite yung nangyayari. So,
Opo.
I think it boils down to the nuclear stability or yung property ng nucleus mo. Because your nuclei, radioactive nuclei, they're really um, we cannot easily predict them, no, theoretically speaking. So instead, uh, kapag mga nuclear reactions, Josh, yung lahat ng tinuro ko sa'yo, yung alpha, beta, etc., those will be major reactions lang, no? So, kasi yun yung na-observe natin experimentally speaking. Ito yung sinasabi ko sa'yo na marami pang pwedeng aralin sa nuclear chemistry, experimentally speaking. But since they are really unpredictable, yung nucleus and unstable siya, you can also undergo several modes of decay. Possible
Opo.
explanation mo, yung sinabi mo na merong irregularities with your nucleus. Okay?
Opo.
Ayan, so alpha decay, ayan, balik tayo dito. Really important. And then kapag beta decay, Josh, ano yung particle mo?
Plus
By the
Z
way, this
plus
is
1.
set.
Yun lang. Z
A is
plus 1,
equal to,
0. Walang nangyari po.
okay, so no
1
change. Then ang Z mo ay plus 1. Tapos ano yung particle na
yung ano po pala,
i-release?
saan po
Mhm.
galing yung mass po ng neutrino?
Neutrino.
Ay,
Dun
anti-neutrino po.
sa
Saan
ano?
po galing yung mass po ng anti-neutrino pag na-eject po yung electron? Galing po siya
Mhm.
sa neutron itself?
Yeah, I think if you will recall, pag nag-undergo ka ng beta decay, ano ang na-produce mo aside from the beta particle?
Electron anti-neutrino.
Mhm. So electron anti-neutrino. So if it's an electron anti-neutrino, uh, yung mass niya ba ay merong mass yun kasi anti-neutrino siya and electron anti-neutrino. Yun nga lang hindi siya ganun ka nakikita, no? So kapag beta decay, you're actually releasing a electron and then ang isang proton mo ay uh, neutron mo ay nagiging proton. Tama ba ako pag beta decay?
Abo.
Tama, no? Neutron mo magiging proton, right? May
Abo.
difference to, right? Sino mas mabigat? Alam ko mas
Neutron.
mabigat to ng onte eh. Oo.
Neutron.
So yung
Saan
difference
po galing
nito,
yung... Abo.
ayan. Dito ito yung parang pinaka-possible explanation, no?
Yun
So
nga
yung
po yung
difference
tanong ko
in
po kasi...
mass, this can lead to
Abo.
uh, mass of other particles.
Yung mass po ng electron tsaka electron and the antineutrino,
Mhm.
they don't account for all of the
Mhm.
mass.
Yeah.
Dito.
Ibig sabihin, meron ka pang may ine-expect pa tayo, no, na other particle na pwede ring mabuo. Pero ano yan? Um,
Obo.
hmm, go ahead.
Kung wala naman po na eject na energy, dapat may isa pa pong particle.
To account, no, for the difference. To account for the difference of your neutron and proton.
Obo.
So, ay wait lang, may tanong ako. Nasabi ba kung ilang uh, anti-neutrino din yung na-produce? Or what?
One na po.
Hmm. If that is the case, medyo siya, no? Hindi nga siya nagtutugma. Kasi kapag ito ay 1.07 ay 1.008665 yata itong neutron eh. Tapos tong proton ay 1.007825, something like that. So may difference talaga sila na medyo malaki din. And this cannot be can be accounted only for electron, no? So it means you will form other particles. I think ang pinaka dito explanation, Josh, may iba pang particle na nabubuo. Possible ha. Or energy might be released but impossible din naman na hindi natin ma-detect kasi kahit small change in mass dito sa nuclear chemistry, tremendous amount of energy, no, can be formed. So um I think pwede ring sa kada decay, if I'm not mistaken, you can also form energy. Parang hindi lang siya pinapakita sa mga equation, pero may energy na nabubuo per
Ah,
decay.
energy ba po?
Hmm. So, yeah. Nagiging ano siya. Not really ano ha, part really sure with this, but I'm thinking baka kunwari yung kapag nagpo-form ng nag-undergo yung atom ng alpha decay or beta decay, we know that alpha particles or beta particles can be produced, but aside from that and other particles, no, aside from the main particles, um, might be they're also releasing small amount or possible energy. Yun nga lang, hindi na lang siya pinapakita siguro sa mga books, no? So marami kasing forms ng energy na pwedeng mabuo, like heat or light, etc. So, di ba remember some of your radioactive nuclides, they are glowing, nag-glow sila. So some of
Opo.
the energy might be converted into light or other forms of energy. Ang iniisip ko naman, baka enough ba yun to cover the remaining mass, no, ng neutron proton. Anyway, that's my that's my answer to your question, no. So
Opo.
saan galing yung mass ng antineutrino mo? That's the difference between neutron and proton. You can form other particles, and aside from that, energy, no. So energy, we can account the energy released when you perform beta decay or alpha decay. Like magugulo sila, mag-heat up. So yun nga lang, baka minimal din yung mass change dapat. I'm not really sure with this one. Okay, so yan.
Opo.
Next, for this one you have protactinium, yung product. Okay, correct. Thorium dapat yung mabubuo mo. Eh bakit number 3 na ako? Check ko muna yung sagot mo sa 2 ha. For number 2, correct. Dapat polonium yung sagot mo. Okay, correct. Then for number 4, so 4 na tayo, radon. Okay, alpha particle dapat plus polonium 218. Bakit alpha particle yung sagot mo dito for
First of
this
all
one?
po, yun lang po yung decay niya. Tsaka,
Okay, and
dapat po
yung Z
yun yung
niya ay
greater than 83. Siguro naman po
okay.
alpha.
Mhm. Correct. So for number 5, C. Ah, okay. Beta decay, correct. Ito madali kapag may isang binigay eh, no? For number 7, it's ayun, ito. Number 5, beta decay. Number 6 pala. For number 6, that will be anong sagot mo? Okay. Anong decay ito?
Beta rin po.
Bakit?
Ah, mataas po yung mga neutron to proton ratio.
Okay, what's the neutron-proton ratio for this? For carbon-14? Of course,
I
we
don't
know, no, carbon-14 will decay via beta decay. Kasi naaral natin to, eh, no? Yung carbon-14 dating, no? So, according to carbon-14 dating, it will undergo talaga beta decay. But of course, we need to have an explanation for this. So, the neutron-proton ratio for carbon-14 ay
1.33.
1.33 versus carbon-12. Carbon-12 ay
Carbon 12 by 1.
okay. So, kitang-kita, dapat beta decay talaga siya.
Meron po palang carbon 8. Alam niyo po yun.
Oh, carbon 8. Ang alam ko lang ay hanggang carbon 11 at
Na ano
carbon
na
10, I don't
synthesize
know.
na po yung carbon 8.
Grabe yung carbon 8. Ang ano nun, sobrang tindi nung nuclear, effective nuclear charge kasi ang onti ng neutron mo, eh, no? Uh, anong half-life? Baka very really unstable siguro yan.
Very
So,
unstable nga po.
number 7, you need to form phosphorus. Okay, correct. So, 32 and phosphorus. Okay, correct. So far, wala ka pang mali sa dito. Okay? Move tayo sa number 8 to 8 to 9. Ayan, ito. Ayan, go ahead. Ayun, so meron ngang energy, Josh, na nare-release, no? So, according dito, sa isang nabasa ko,
Yung
the
medyo,
total energy of the... Ay, hello. Ayan.
abo.
The total energy of your beta decay process is divided between the electron. So, may speed ang may eject na electron, di ba? So, may kinetic energy yun, Josh, aside from the mass. Okay? And then, the antineutrino, tsaka yung recoiling nuclide na nabubuo. Okay. So, yun yung mga pagkukuhaan mo ng differences. Okay. So,
Tapos na ba?
okay, let's see. For number 8, okay, so when you combine deuterium tsaka tritium, no, you'll form alpha particle and neutron. Okay, good. Tapos, correct tong number 8. Correct yan. For number 9, oops, what's happening? For number 9, Einsteinium, ang mabubuo mo dapat ay, bakit parehas neutron to?
Ah, nagkamali po nagkamali ng kopya.
Okay, go ahead. Sige. Ano dapat yung answer mo dito?
Hindi po na may believe yung abo.
Ayan. Okay, correct. So the answer dapat ay Mendelevium 256101. Okay, good. Ayan. Tama ito. Then next, number 1, set B na tayo. Number 1, magnesium and proton, you form alpha particle and sodium 23. Correct. So more on balancing ito, Josh, ha? So remember, kung hindi mo man ma-predict yung particle na mapuproduce, ang tignan mo yung A tsaka yung Z, no? So, ito total mo lang naman sila. You just need to remember that the A and the Z must be balanced for both sides of your reaction, no? Nuclear reaction. And then for number 2, so when cobalt is reacted with deuterium, you form cobalt 60 and a neutron is released. So, ito neutron emission to, no? This is a neutron emission.
Kailangan matindi
Yun
na
nga
po
lang,
yung
para magkaroon ka ng neutron emission, ang bigat nung iaano mo, nung ibobombard mo kay cobalt. This is how you form cobalt 60 eh. Okay? Deuterium yung ibobombard mo kay cobalt. And cobalt 60 na siya. Okay, wait lang. Asa ka na? Number 3. We have, ano to? Lang double check ko din kasi yung sagot mo eh. Number 3, uranium 235. And then, pop. Ayaw niya talaga mag-ano. Tsaka neutron. Okay. Ito alam natin to. Uranium 235 tsaka neutron. Ito ay ano,
kailangan
Josh?
i-pass natin. Yung fission.
Correct. Ito ay process ng fission, no? So, this is nuclear fission. Automatic, alam natin, no? For every neutron na binombard, you form 3 neutrons, no? 3 neutrons yung mabubuo mo. Okay? So, this is also correct. Number 4. Chromium. Tapos alpha particle ang binombard mo. You form neutron at ang sagot mo ay iron. Correct. Iron 5626. Good. Then oxygen. What's the neutron-proton ratio for oxygen?
Very high.
Mhm. Oxygen 20. For oxygen
1.5 po.
20, 1.5, no? Yeah. Tapos, ang oxygen 16, para sa normal lang, ay, of course, this is 1, no? So, kapag ganito, Josh, anong decay mode ang most plausible? Mataas ang neutron-proton ratio.
Beta
That
po.
will be, okay, automatic, beta yan. Correct. So, beta ito. Then finally, number 6 pala muna, we have iodine 135. So, ang iodine 135 ay anong neutron-proton ratio niya? Ulit-ulitin natin to, no? Para at least sobrang sanay ka na.
1.54 po.
1 point.
54.
Again, 1 point what?
54 po.
Okay, 547, no? Okay. Versus the normal na iodine atom. Ang normal na iodine atom ay 127.
Opo.
127. Anong neutron-proton ratio? For iodine, 127.
127.
Iodine, 127. So that we can really prove, no, that this one will
1.39 po.
undergo beta decay. Very good. 1.39 or 397, 396 rather. Okay. So this one can really undergo beta decay. Okay, correct. So tama na tayo dito sa number 6. So far, so good. Wala pang mali. Let's now proceed with number 7, 8, and 9 muna. 7, 8, 9. Yan. Itong tatlo. Ay, sorry. Tama. 7, 8, 9 lang muna. Yan. So, ayan, potassium yan. You're good na ba?
Opo.
Okay. So, should be um, for potassium or yeah, potassium 40. Of course, we know this already, no? Na ang mode of decay, yung main mode of decay ni potassium 40 ay ano? Should be what?
Beta po.
Should be beta. Pero please take note, we know that sa potassium argon dating, ano ang minimeasure natin na decay, Josh?
Yung ano po, yung electron capture.
Very good. Yun, akala ko makakalimutan mo na kagad eh. Electron capture. Sulat mo nga ulit yung electron capture for potassium 40. And ano yung mabubuo niyang product?
Ah, okay. For,
Okay, good. You're really comfortable now with nuclear reactions. So kahit ano na yung iba to sa yung nuclear reactions, lagi mo na yung maano. Okay.
hindi pala,
Yan,
dito pala.
electron. Good. Argon na. You form argon 40 and that is what we measure no in argon potassium or in the potassium argon dating. So ito. And this accounts for how many of the decay mode?
11% po.
Ayun, lagi mong tatandaan yan. 11% ang electron capture ni potassium 40. Then majority, 89% will be undergoing calcium 40 decay, no? Or to form calcium 40 via beta emission. Okay, for number 8, that will be an alpha particle will be produced from cobalt bombarded with neutron, correct? And then for number 9, we have cobalt bombarded with, uranium-235 bombarded with neutron. This is another what? Ano to? Yung number
Another,
9.
ano po, neutron capture. Not really neutron
Okay.
capture, but sort of, parang neutron collision po.
Or, this is also an
Or neutron
example
capture
ng
talaga.
nuclear fission. Nuclear fission pa rin yan, no? Kasi di ba recall, uranium-235 ang isa sa pinaka madalas na fuel, the most common fuel for nuclear fission. So it will undergo several nuclear reactions. Not only yung barium radium na yung usual na nakikita natin, no? But you can also form other elements. Like what I mentioned, Joshua, last time, yung nuclear fission of uranium-235 involves 30 complex, 30 nuclear reactions. So it's a very complex process. No? Okay, so far, so good. Tama pa lahat. Okay? Sorry, ayan. Next. Proceed tayo. Ayan, natural radioactivity muna. So, go ahead. So, you're given with an element and then predict lang yung series, no? Ayan, chinek ko na to. So, your answers are all correct. So, pag yung thorium will undergo alpha decay, So minus 2, so 232 magiging 228. Then 90 minus 4 for the atomic mass. And then for the atomic number, 90 minus 2, it will become 88. So radium ang mabubuo. Then it will undergo beta decay from radium plus 1. Automatic yung atomic number, you form actinium, and then 228. Then undergo another beta decay, you now form thorium again, but this time the atomic mass will be 228 na, no? Then next, number 10B. So this is also correct. So uranium-235 alpha decay minus 4 for your atomic mass. That will be 231. Then 92 minus 2, 90 thorium. So correct yan. Then undergoing beta decay, this will add up one atomic number, 91. Protactinium yun. And then the mass will still be the same, no? And then alpha decay minus 4 again 231, so 227 then 89. Okay. Then finally, ito medyo parang ka-challenging lang siya kasi working backwards to, no? But we know already it's an alpha decay. So 233 plus 4 lang to, magiging 237. And then 91 plus 2, right? So magiging 93. So that's neptunium. And then yung protactinium mo undergoing beta decay, you still have the same mass, but you'll add one atomic number, so uranium yan, or add one proton, then an alpha decay. So you now have thorium, 229, then 90. So with this, parang ano to Josh eh, yung natural radioactivity, or if you're given with a radioactivity series, parang you can target certain elements, no, that you want using this natural radioactivity or using nuclear transmutations, no, or transmutation reaction. Okay, so let's now proceed with letter B, nuclear stability or nuclear calculations. Parang mas ano yun. Okay yun. Yun yung term natin. Ayan. So, number 1. Sige. For number 1, basahin ko muna. The radius of uranium-235 nucleus is about 7 times 10 to the negative 3 picometers. So what we need to do here is calculate the density of your uranium-235 nucleus in gram per cm cube. So please
Ano
assume
po,
that the atomic mass is 235 amu.
ano po yung EMU kasi po sa ano, EMU 2 grams.
Atomic mass unit?
Abo.
Conversion. Tama?
Abo.
Ayan. So, that's 1 gram is equal to 6.022 times 10 to the 23rd amu. Avogadro's number.
Okay, I forgot.
Okay.
Bro. Mas.
You might want to share your screen. Gusto mo ba? Kasya ba siya? Hindi, share screen ka na para at least masasave mo yung image. No? I'll stop sharing lang. Then, write number 1 so that you can save the image later. No? So, lagyan mo PS15 number 1. Because we're now in PS15.
Bro.
Wow, PS15.
Bro, lag. Everything lagging. Ayun. po yung tama pong pagsulat na raw. Mukha po siyang P kasi eh. Ganun po. Dapat po siya parang ano eh, parang, parang P pero rounded din po. Wala pong sound.
Nakamute.
Ay, sorry. Ayan. So, you can draw your raw sign, no? Naka-curve yung tail. Pero ayan, you can you need to calculate now the density.
Hindi po marinig.
Naka-mute mo.
Nakamute mo.
Yes po. Okay, correct. So you calculate first the mass, and
Imagine
then
using
calculate the volume.
when ano po
Ah,
when you use a negative ano po negative exponent for SI units.
and you use now 7 femtometer. Okay, so from femtometer, then convert that to cm. Okay, so continue. Mass over volume.
Yay.
What's the answer for this one? Sige, calculate mo for the volume. Di mo pwedeng ilagay yan yung kapag ano yan, kapag sa mga formal na reports, yung kunwari answer equals I don't know. Oh, you calculate the volume here. Ito, yan, correct.
na ano po, wait lang po. Kaya nalagay ko pala po yung answer, buto lang.
Feeling ko, dinire-diretso mo siya sa calculator eh. Okay, correct. Good. So the answer should be 2.761, correct? 716 rather, times 10 to the 14 gram per cm cube. So really, really dense, no? Yung uranium 235. So it's highly ideal then to be used in nuclear fission because it's really dense. Okay, next. Number 2. Okay, so do you have a copy naman, Josh, no, ng practice set? So for number 2, I'll read. Estimates show that the total energy output of the sun is 5 times 10 to the 26 joule per second. Imagine mo, no, per second, the sun is producing 5 times 10 to the 26 joules of energy. So what is the corresponding mass loss in kilogram per second of the sun? Of course, we know that the sun will be using up its mass to produce energy din. Sige. Calculate number 2 now.
Ah, hmm. Brr. Wala pong sound. Wala pong naka-muted po.
Okay. May sagot ka na?
Abo.
Okay. So for number 2, let's see. Mhm. Okay. So what equation will you use there? Okay, correct. MC squared. So E equals MC squared. So therefore, the change in mass should be energy all over C squared. So, grabe, 5.5 teragram per second or 5.5 times 10 to the 9. Correct. So 5.56, that's the answer. 5.56 times 10 to the 9 kilogram kilograms per second. So imagine mo, no, Josh, the sun is losing that much of its mass to produce a certain amount of energy, which is approximately 5 times 10 to the 26 joules per second. Then number 3, I'll read the question in number 3, no? So very simple lang. If 12% of your certain radioisotope decay in 5.2 years, what is the half-life of this isotope? So if 12% lang of a certain radioisotope decay in 5.2 years, what is the half-life of this isotope? That's number 3.
Uh, bro, HN. Moment. Ano po, na-deep song po
I
yung
don't
LNN. How will,
bakit
how, cause
HN yan?
that is, how will we deep song po LNN, Minding Age?
Yeah, if you will place them too much, no, beside each other, too close beside each other, nagiging H siya. Okay, good.
Bro,
Oops. Ayan. Tama yan, you can use. Pero you can place number 3 sa taas na lang, Josh. Para pwede ka pa mag, ano, number 4.
ano po, me when I harness technology.
OMG. Akala ko nga buburahin mo pa eh. Ayan. You can
So
maximize
po,
the space. You can move
this is
it
called,
up.
this is called po big brain time.
You can move the whole number 3 and other terms, no? Or right, leftmost pa. Kung gusto mo mag, ano. Okay, good. So you just rearrange the equation, no? To have the ratio of your 80 over AO. Okay, that's negative KT. So ln 80 over AO equals negative KT. So K is half-life over ln 2. And then rearrange the equation na. Sige, go ahead. Is that a bunny? Okay. Just substitute the values now. And then we will now get the we can't get pala the half-life ano. So i-rearrange mo pa yung equation.
Uh, something. Okay. So, ito po yung tawag po na the power of the calculator. Anyway, I will shift solve. Ay, solve ko lang po. Dito. This is, Ba? Nadidip song ko po yung L and N, nagiging H.
Or actually you can rearrange the equation no to have the t1 half on your left side na lang of your equation so that you can easily um, just substitute the values no once you have the equation already.
Bro, why? I'm being tormented.
Why? Okay.
Wala, nangyari. May nangyari po.
No, our dog is doing something. Ano na naman kinuha? Okay, that's a good ano. You now have the equation, no? So regardless naman you can regardless of the form of the equation,
Ito po
as
yung
long as
tawag
you
na
will
ano
still
po.
arrive.
It is
Mm.
ito po the only way to do this is with the calculator. Otherwise, it will be complete pain.
Okay, so ako kasi fan ako ng 1 gram then 0.88 na yung ginamit ko eh, no? Tama ba ako? Yes, 1 gram 0.88. Pero you can use that. It's still 100 pa rin. Oh, negative!
Tang, 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 tang.
Ibig sabihin may mali ka.
No! No!
So you're calculating T1 half.
Ano nangyari?
You try to repeat sa calculator mo. Baka you might be pressing wrong numbers again.
Negative yung ano mo?
Wala, same yun eh.
Huh?
Josh, ako kita ko na kagad kung ano yung mali mo. 80 over
No!
AO. Please take note of this. 80 over AO.
Bro,
Hmm. Sige, tignan mo yung ano mo, substitution. 80 over AO. Ayan,
my
nakita
force,
mo na.
ito po yung tawag na my force when.
Hindi ko na nga sinolve muna eh, kasi alam ko mali ka na dun sa ano, sa substitution eh. Yun ha, careful ka dyan. Substitution na lang siya.
Wait lang po.
Sige, i-double check mo yan. The answer should be... Tignan mo ha, analyze the problem, Josh. From 100 grams, it becomes 88 grams after 5.2 years. So do you think the half-life is 6.22 days?
Kaya nga po, it
Hmm.
must be wrong. Exactly. Kaya nga,
Doesn't make sense. Yes, correct. So it means
Eh,
there's something wrong in your equation. Sige, analyze mo ulit. What do you expect for the half-life? Higher than 5.2 or below 5.2?
higher than 5.2.
Correct. Dapat it should be greater than 5.2 years.
Tang, 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 tang. Tang. Tang, 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 tang. Tang, 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 tang.
Ayan. Okay, so ano na na-calculate mo?
I don't know. It still shows up the same way. Something's wrong.
Hmm?
Ano substitution mo?
What's the formula of your K?
What's wrong? Wait lang po. Nitry ko nga po yung ano kong baliktad. Wait
Okay,
lang.
anong formula ng K mo muna? Kasi baka dun ka mali eh. So, di ba, ln 80 over AO, this is correct, equals negative KT, right? But what is the formula of your K? K is equal to what? Okay. So, K is, positive 2 ha? ln 2 over T1 half. Okay? So, with that, check mo kung paano. Ayun. So, yun yung mali mo. Yung ln 2 mo kasi kanina ay nasa taas eh.
Easy fix po. Parang liquid paper. But more accurate.
And then, you can now calculate the half-life, no?
Bro!
What is the half-life now?
Negative.
Oh, it's still negative? Sure?
Abo.
Kasi negative KT siya eh. Eh di dapat may negative ka pa rin dito. Tama ba ako?
Tama pala. Yes.
Mhm.
Pero naman po, kung negative, negative. It's not,
Hindi, mawawala na yan.
it's less than 1 year.
Oh, ay sorry. Ay, naku, nawala ako. Di pala ako nakaano. Ayan. Rearrange the equation again na T1 half lang ang may iwan sa left side because dun ka nagkamali eh. Dapat T1 half lang ang may iwan.
Ayaw po magalaw eh. Bruh! Imagine.
So again, you start with that equation and then make it into T1 half.
Bruh, literally, 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 literally,
Then now try to substitute the values. So meron ka ng negative ln2 times t all over ln a t over ao. Substitute mo na yung values mo. So this will be handy, no? For the next problems na may encounter natin. Ito na lang. Baguhin mo yung nasa taas, Josh. Ito, rearrange mo na to. O dapat hindi sa numerator yung ln 100 minus 12 over 100. Dapat nasa denominator pala siya.
So sabihin, ito po yung pinnacle of laziness.
What?
Ine-negative
Move mo
to
na
the
lang.
negative 1 ko na lang po. Ah, genius.
Okay, correct. Yun, finally, nakuha mo din yung answer. So, that is the answer. 28.2 years. Okay. That's the answer. Correct. Next, we'll proceed with
Yes. Ano?
eto sir yung sagot. Nakuha niya na po. Pero, ito pinapa-rearrange ko to sa kanya kasi baka pag pinicturean niyo po, ito yung makuwang equation eh. Rearrange this according to your derived equation. Kasi hindi ayan yung nakuha mo eh.
Na-rearrange mo.
Okay. Ito po talagang ano.
Ayan. Good. So, anong ginawa mo? Ni negative 1 mo. Naku, baka maano niya yan. Pag pinicturean mo, hindi mo mapansin yung negative 1 dyan. Baliktarin mo na lang. Rewrite that.
Daya. Ano yun?
Rewrite that.
Ano ko na?
Yan.
Ito po, ano po talagang, ito po yung tawag na innovative.
Alam ko na yung gagawin. I-group mo sila yan. Tapos angat mo lang. Hindi, angat mo muna. Wala. Mahihirapan ka mag-move niyan mamaya kasi nagpatong-patong na siya. Tingnan mo. Mamumove mo na rin yata yung iba. See? Na-move mo na rin yung P.
No!
I told you. Move it sa taas. Yan.
Destruction, emotional damage.
There. Okay, correct. There you go.
Inaiwan.
Para makuha mo yung
Bro,
para makuha mo na yung
where it
what
go?
happened. Na-enlarge.
Na something happened.
Na-zoom yung yung screen mo.
Where am I?
Zoom it out. Oop. Okay, good. Ayan. Hindi pa siya kasama.
Literally 1984, just die. Okay.
Just sulat mo na lang.
I just reincarnated this book.
Okay, good. Next page ka na. Number 4 tayo. Para madami tayo matapos tonight. At least hanggang 6 sana. Okay? So, number 4. Next page, please, Josh. So, for number 4, the radioactive nuclide cobalt-60. So, of course, we know cobalt-60 is being used sa medicine, di ba? Has a half-life of 5.27 years. So, yan yung half-life niya daw. Calculate the mass of cobalt-60. Again?
So does this mean that your therapy will last more than 10 years?
Correct. Oo. Kung kung cobalt-60 yung ginamit, no? For therapy, radioactive therapy.
Yun po yung tawag na 1984. And living biohazard.
But technically speaking, or medically speaking, yung cobalt 60 dapat control yung amount mo, no, so that it will not complicate your biological systems. Tingnan mo ha, calculate the mass of cobalt 60 that remains from a 0.01 gram sample. Ganun lang kaonte, no? From a 0.01 gram sample of the nuclide after 1 year has lapsed. So kunwari, ayun, nagpa-nuclear therapy ka, cobalt 60, in-inject sa'yo kunwari 0.01 gram sample. So after ng isang taon, gaano kadami na lang yung cobalt 60 sa katawan mo? Okay.
I don't know.
So of course, cobalt will undergo radioactive decay. Ano nga ulit yung cobalt 60? Ano yung decay mode niya? Naalala mo?
uh,
Cobalt 60.
I forgot. Gamma? Yes, gamma. Wait a minute. If it's gamma, then it should just decay into itself.
No, cobalt 60 hindi siya gamma.
What is cobalt 60?
Cobalt 60.
Uh,
Cobalt 16, no? Parang gamma dapat yun. Wait, let me check.
so technically, it's not radioactive. It's the excited cobalt
It's
60 that's
radioactive. It's still radioactive, no?
technically
The
po the cobalt.
metastable.
Yes po, yung
Yeah, gamma
metastable.
radiation.
Technically,
Yung
the cobalt
metastable form.
technically the cobalt 60 itself is not radioactive, but the cobalt 60M,
Oh,
ano
yeah.
po yun? 60,
As
60M1? But
60M cobalt 60.
why don't they put like this po when they write? They just put cobalt 60. Is cobalt 60 actually stable?
Yeah, actually cobalt 60 is stable na yun, no? So dapat
So they
supposed to
just
be
put
they
cobalt
should be
60M
writing cobalt 60M. I think
because
that is
if they put
a common idea na automatic if it's cobalt 60, like technetium din, no? If we will use technetium 99,
they usually put
automatic, it's the metastable form. Mm. Baka na to, historical na to, no? Or yung conventional. So since by convention, they use cobalt 60 na, or they wrote cobalt 60 in medicine as Co60. So nasanay na lang sila.
whoever
Okay,
whoever did not write whoever did not write the cobalt.
balik tayo sa problem. Uh, Calculate the mass of cobalt 60 that remains from a 0.01 gram sample of the nuclide after 1 year has lapsed. Okay? So, ayan. So, hindi, you start with ln AT over AO. Doon ka pa rin.
Ito
Nako,
na po yung formula
erase.
eh. Ito na po yung formula. Pag
Pakita
ano
mo
po,
pa rin siya.
ito po yung ginawa ko pong mga master formula po eh.
Hindi, master formula yan. Pero you need to see there, or we need to see there how did you arrive sa equation na yan. No? Very good. ln AT negative KT equals pa rin. Oh, what's happening?
Something. Bro,
Oh, you write number 4. Number 4 na.
since T is
Sulat
equal
mo
to 1
muna
and
number 4.
so i-integrate ko na siya.
You write number 4.
Ay, wala na pong room pala. Where the room? Bro! It
Okay, good.
glitch.
Yan. Para at least
Glitch moment.
Okay, good. Oh, what's happening?
The something happening. Too. Yay.
Okay, kinombine mo na siya. Nasaan na yung T mo?
Where the T again? Ah, yes, T.
Okay, and then, so you're after with 80, correct, no? We're after with 80. Yun yung kailangan nating makita.
Actually, maybe I should have kept the negative.
Actually, dapat hindi mo muna siya kinombine with LN2. Kasi mas mahirap na siya. Okay,
Bro.
niremove mo na. O, tignan mo na, wala ulit yung 2.
Ito pa yung tawag no 1984. Mhm.
Okay, LN2 over half-life. Okay, good. 1/2 times LN2. No, yung buong yan, Josh ha, yung negative T over T1/2 times LN2, lahat yan ay exponent ng E mo. Okay? Lagyan mo open and close parenthesis dun sa E. No. I mean dun sa exponent niya. Sorry.
Wait.
Exponent of E. There. So that we can clearly see that it's ano no. Okay, yan. Pwede na yan. Then substitute the values. Then try
Imagine
if you will get the same answer. Should be. You should have the same answer.
It unfortunately is not the same answer.
Why? What's the answer?
Pabaliktad po eh. It increased in
Ay,
mass, which is probably impossible. Very highly improbably possible.
sige, tignan. Check natin yung equation mo, ha? Or baka mali ka sa calculator mo. So, correct.
Hindi po.
ln 80 over AO equals negative KT. Negative KT is equal to, okay. Ay, asa na tayo? K is equal to 0.693 or ln 2 over half-life. ln 2 over half-life, correct. So, negative t times ln 2. So, therefore, sige, isusulat ko yung substitution ha. So, 80 is equal to e raised to, what's your negative t? What's your t here?
1.
1 year, correct. All over, what's the half-life? Binigay naman
Ayun!
yung half-life eh.
Nakaano po siya. That's the reason.
Why? Then times ln 2, ay nako po. Then times AO. Your AO is 0.0100 gram. Okay, ayan, nakuha na natin. Same na tayo. So, you should have a remaining of 0.00877 gram of cobalt 60. Okay, so this should be the answer. Okay, on number 5, Josh. For number 5, at a given time, there are 1.2 milligrams of a radioactive substance present. So after 6 hours only, no? So after 6 hours, 0.3 milligram remaining. What is the half-life of this radioactive substance? Mabilis to. Mabilis to,
It is,
Josh. So,
I have no idea. So,
At a given time, there are 1.2 milligrams of a radioactive substance. So 1.2 milligram siya. So after 6 hours only, 0.3 milligram na lang yung na-remain. So what is the half-life of this radioactive substance? Oh, you're right, number 5.
Ay, 5.
Right mo muna,
Nakalimutan ko,
number 5.
bro. Me after forgetting.
Actually, may formula ka na ng half-life. Balik ka dun sa number 3 mo. Kasi similar sila ng tanong eh. Ayan o. O, diba? So,
Bro.
ln 2 times t over ln 80 over AO. Okay. What is the answer now? Okay, answer, Josh. I need answer.
Yan na po.
1 over 12 of what?
Of something. Hours. So that
Sure?
is 5 seconds? Ay, hindi, 5 minutes? Yun po yung lumalabas eh.
Check mo muna yung equation mo. So, dapat pag ginamit ko equation mo ha, negative ln 2 times time over ln 80 over AO. Sige, balik ka. So, T1 half. Gagamitin ko yung equation mo. Sige, go back to page 2. Or go now to page 2. Okay. So, T1 half is equal to negative ln 2 times T all over ln 80 over AO. Okay. So, what's your T here, Josh? What's your time? After what? 6 hours, right?
Abo, 6
Okay, 6
hours.
hours. Over ln, what's your original mass? Your original mass is what?
1.2. And then the other one is
1.2.
the left mass.
Okay, so after 6 hours, it became what? How many grams? Or how many milligrams?
0.3.
0.3. Okay. O sige, o. Evaluate that. O calculate mo. Para at least mako-compare natin. So this one is in hours. Then convert that into minutes.
So tama pala po yung formula. Okay. 3 hours, exactly. Bro. When
3
erase.
hours ang sagot?
Yes, abo.
Sure ka? Sige. You try to calculate.
Yun po yung lumalabas eh.
Wag mo lang ganitong ginagawa mo eh. Nag-i-input ka lang ng numbers without analyzing ano ba yung mga
Exactly the
numbers
same.
na yan. Yes.
3 po.
Sige, try ko ha.
3 hours rin po yung lumalabas sana eh.
And then,
Saka rin po, kung diba 1.2, tapos pag after 1 hour, magiging 0.6. After another hour, magiging 0.3.
okay, good. Tama. Correct. So, should be 3 hours. Tama. Okay, so we have 3 hours. Next, number 6. So, I think this will be our last problem for today. No? Medyo mahaba din naman itong 6. So, the atomic mass of thallium 205 So atomic number 81 is exactly 204.9744 AMU. Calculate the nuclear binding of this nucleus and the corresponding nuclear binding energy per nucleon. So ito yung very similar dun sa ginawa natin. TL20581. Good, tama yan. Masang neutron, masang proton. So
Uh,
that's TL20581.
so
Okay?
how many neutrons? 205
Yan,
minus
calculate mo.
124, 124, 124. Okay, 124.
Okay, good. So 124 times the mass of neutron, then 81 times the mass of proton. So to guide you, the mass of proton
Nakaano po sa calculator?
is
Okay. Uh,
hindi, pero nakaamo ka ba? Nakaamo na
I
siya
don't know.
sa calcu?
Naka-gram shot ako eh.
Kasi nakaamo yan eh. Grams yan. For proton, 1.007825 amo. Then for neutron, 1.008665. 8665. That's neutron. No, the other one is okay. Baliktad ka.
Jesus.
Yan, correct.
Ano po,
Proton,
when I'm
neutron na
too
siya.
lazy to erase. Bro,
Mhm. Oh, minum mo pa. Oh, genius.
sakit.
Okay.
Ano? What happened?
Anyari?
Extremely high frequency po na sound.
What happened?
Ang taas po ng ano.
Yung mga iba kasing katulad niya po, ano eh, meron tinatawag na hypesthesia, yung hyper yung mga senses. Lalo ng bata nga po siya, mahirapan siya pakainin mo, tsaka yung kunyari manonood, yung may makikinig ka ng music, sa kanila parang sobra na.
Mm-hmm.
May pinsan nga yung
Okay.
kuya niya, pinasama sa akin sa movie house. Parang sa movie, nag-hysterical yung bata, parang sa kanya, sobra na, May
Sobrang
ganun po
lakas
sila
na.
eh. O kaya, kunyari sa paglasa rin,
Mm-mm.
masyado pong yung mga hypesthesia ang tawag sa med po eh.
Sensitive masyado yung mga ano nila.
Mga senses po. Wala na? Okay ka na? Wala na?
Ano yan? Minsan po parang ang lakas eh. Parang sakto po sa yung resonance.
Okay, yung mga kamay po. Minsan parang sa kanila, sa kanya parang masyadong sensitive. Pero nabawasan actually yan.
Yeah,
Kasi kami, malakas kami
hypersensitive.
magpatugtog ng
Baka siguro may nag-ano radio sound. Parang ano po, radio static na sobrang taas. Ay, hindi pa parang yung feedback sa mic.
Correct. Sakit
Yung
nga
super
yan sa
taas.
tenga.
Ang ganun.
Okay, so reactants minus product. So parang ang product mo will be your atomic mass. So this one, no? So ito yung P mo. And then this would be your reactants. Then of course you'll have there at the difference. So sige, go ahead. Continue number 6.
What? Nangyari?
What? Yan. Nilagyan ko lang ng products sa reactants yan para guided ka. You need to get now the values for your protons and neutrons.
What happened? Okay, I'm in circle 2.
That's the change in amo na or the difference in masses. Sige, I'll help you out dun sa ano ha, solution mo para kapag sabi ko nga kapag pinicturean nyo or
Ayun na.
later sinave mo yung image 1.007825 times proton is 81. So this should be 81.633825. And then for your neutron, 1.008665 times 124. It should be 125.07446. Then pag tinotal ko, plus 81.633825, this should be yan, plus ito 206 points. Ayan, medyo malaki yung difference, no? 708285. And to get the difference, 206.7825, no? So, minus 204, dapat negative yan, 9744. 1.73333885, correct. So this is the difference. So what will be the uh, change in energy? Or delta E mo. So using the MC squared. So ayan, from there, you can now get the nuclear binding energy per nucleon. Or binding energy per nucleon. Diniretso mo na yan na ano, no? Nuclear binding energy. Usually, nuclear binding energy, Josh, is expressed in kJ per mole. So, pero you can get now there the joule per nucleon o kaya kJ per nucleon. So, 1 point. Ayan, ano na to? kJ per mole na to?
Abo.
Okay. So, what is this? This 2.58768 times 10 to the negative 3 kJ per mole. Ito yung NBE. Okay. Nuclear binding energy. Then your energy per nucleon is
Yes, wait.
Ganito. Ganito.
Wala na akong name.
NBE lagay mo.
Wait. Ayan.
per nucleon na ha. So by the way, the conversion of AMU meter squared per second squared is 1 para maging kilogram siya, 6.022 times 10 to the 26 AMU, no? So para at least makuha mo yung change in energy per nucleon.
Ano yun? Hindi ko naiintindihan yung sulat mo.
Nag-bleach.
Okay, nuclear binding energy per nucleon. Yeah, sir. NBE per nucleon po yung sinusulat niya. Should be joule per nucleon. Divide 6.02 to exponent to the 26.
Huwag magkakadikit.
So,
Hindi mo nakadikit na ito mo
mhm.
nag-erase.
Can you double check this one, Josh? Okay. Um, sige, tama yan. Divide 100.
Yung dash mo ano yun? Isang
Dash.
dash lang ito.
Plus 81. Okay, correct. So, 1.26 times
Dash.
10 to the negative 12 joule per nucleon. Very good. Yan, yan. Binding energy per nucleon is actually equal to 1.264 times 10 to the negative 12 joule per nucleon. Okay. So, tama yan. And then, ang NBE mo, correcto. NBE mo is 2.58 or 2.59 times 10 to the negative 13 kJ per mole. Okay. So, but Joshua, naka-negative yan kasi it indicates na ano yan, yung difference sila ay or deficient. Deficient siya ng mass.
Opo.
Yung sa ano, sa NBE, 'di ba 'yun yung usual nating ina-express. Dapat yung NBE mo naka negative siya. Just to indicate that tsaka deficient yung mass mo no na nabuo. kJ per mole 'yan. Okay, kJ per mole. Okay, same value naman tayo na nakuha. Okay. So I think that's it. So that will be we'll end our session tonight sa number 6. So hopefully Josh, number 7 then to number 17, medyo madami-dami pa to. We finish everything na no on Thursday. Okay? So
Okay
ayun.
po.
Thank you so much po for tonight and enjoy
Oh,
the rest of
sir,
the
thank
night
you
po.
very
Stay
much.
safe and stay healthy po.
Ready
Thank you din
po.
sir.
Thank you
Ingat
po.
po lagi.
Yes, okay
Salamat
po.
po. Enjoy dinner din po.
Okay
Sige po.
po.
Okay po. Bye-bye po.
See you on Thursday po.
Okay po.
Okay po. Bye-bye
Thank
po.
you, sir.